So, question 14. White shapes and black shapes are used in a game. Some of the shapes are circles, all the other shapes are squares. The ratio of the number of white shapes to the number of black shapes is 3 to 7. The ratio of the number of white circles to the number of white squares is 4 to 5. And the ratio of the number of black circles to the number of black squares is 2 to 5. Work out what fraction of all the shapes are circles. Okay, so of all the shapes, so basically we're trying to work out here, it states here that some shapes are circles and all other shapes are squares. And we need to find out what proportion is that in total of all the shapes. So how much out of all the shapes are circles and how much out of all the shapes are squares. Okay, so let's break down each of these ratios into fractions first of all, just so that they're easier to deal with. Okay, so if they're saying that the number of white shapes to the number of black shapes is 3 to 7, we can say that the number of white shapes is the proportion of white shapes out of all the shapes is 3 over 3 plus 7. So you add up the ratios, which is 3 over 10. Okay, and we'll say this is white shapes. Okay, and we'll do the same with the black shapes. So we'll say 7 over 3 plus 7 equals 7 over 10. And this is the black shapes. So basically all we've done here is we've just simplified this sentence into two fractions. Okay, the ratio of the number of white circles to the number of white squares is 4 to 5. So we'll do the same thing here. We'll say 4 out of 4 plus 5 equals 4 over 9. And this is the ratio, this is the proportion of white circles. White circles. And we'll do the same with the white squares. So 5 over 4 plus 5 equals 5 over 9. That is white squares. Okay, so we've done this one now. And then it says the ratio of the number of black circles to the number of black squares. So again, it'll be 2 over 2 plus 5, which is 7. And that is black circles. And you have 5 over 7 are black squares. Hopefully so far it's been straightforward. Okay, we're going to use these fractions to work out the fraction of all the shapes that are circles. So that's the reason why we put these ratios in fraction form, because we're going to multiply them in each other in such a way that we get the fraction of all the shapes that are circles. Okay, so now the way you can look at this is like probability. So let's say, for example, all these shapes, all these circles and squares were in a bag, and you were asked what's the probability of, for example, getting out a black circle, and what's the probability of getting a white circle. And we know from this question that you can only have black or white shapes. So we can use that approach here. We can say, well, the probability of getting a black circle from all the black shapes is 2 over 7 multiplied by 7 over 10. So what I'm saying here is that out of all the black shapes which in this case is 7 out of 10 of all the shapes. How many of them are black circles? Well, it's 2 over 7 multiplied by 7 over 10, which gives me 14 over 70. This can be simplified to 1/5. And we could do the same with the white shapes and the white circles. So again, we can say, well, of the white shapes, how many of them are circles? So we can multiply these two fractions by each other as well, because it's the probability of it being a white shape and a circle. And so you multiply these two by each other. So you get 3 over 10 multiplied by 4 over 9. That becomes 12 over 90. And if you simplify that, that becomes, well, you can divide both by 3. You get 3 over 30. And if you simplify that further, sorry, that should be 4. If you simplify that further, divide both by 2, you get 2 over 15. Okay, and then what we're going to do is we're going to add these two to each other. The reason being, so this fraction, we're going to add this fraction and this fraction. The reason being is that this was the probability, so this line was the probability of how many black circles there are within the total of, the thing is, you may ask yourself, why don't I just take this fraction, because this tells me the fraction of the black circles. But this tells you the ratio, this is a ratio of the black circles to the black squares, not the black circles to the rest of the shapes. So you can't use this. What you need to do is you need to work out what the fraction of the black circles are to the total of shapes there. And that's by, again, multiplying the ratio of the black circles to the black squares multiplied by the fraction of black squares. And that gives you, again, in terms of probability, you can say it's a black shape and a black circle. And remember the AND rule from probability. If you have an AND, then it's multiplied. And if it's OR, then you add. So we've done the AND part, which is a black circle and it's a black shape, and a white circle and a white shape. And now we're doing the OR part, which is that it could be a black shape and a black circle, or a white circle and a white shape. And because of that OR, we now add these probabilities to each other. So if we put these under both common denominator, perhaps multiply this by 3, you end up with 5 over 15, which is a third. So your answer is a third. So work out the fraction of all the shapes are circles. Well, it's a third of all the shapes. So a third of them are circles, 2/3 of them are squares. Okay, go to the next question. Right. A cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13 centimeters. Work out an estimate for the height of the cone. Okay, so what we can do here is we can equate this equation to 98. So 98, or in fact, to make things easier, we can rearrange this algebraically. So V equals 1/3. I'm going to write it like this: pi r squared h over 3. And they want an estimate for the height of the cone, so I'm going to rearrange this formula to make h the subject. If I multiply 3 by both sides, I get 3v, and that equals, so pi r squared h. I'm going to take the pi and the r squared, divide it by both sides, I end up with pi r squared. I'm going to put the equal sign here, and h equals as follows. Okay, so now I can do h equals 9 equals 3 multiplied by 98 over pi, which if they haven't given us, we are going to okay, what seems to have happened is I accidentally paused the video, but let me quickly explain what I've done here. I noticed that it said work out an estimate for the height of the cone. This means that we don't actually have to use the exact values they've provided us with here. They say an estimate, meaning that they're expecting a range of answers. So we can say rather than taking 98, we can take 100, and for 5.13 we can take 5, because those are reasonable enough estimates. So you do 3 times v, which in this case we're going to estimate as 100, we're going to approximate as 100, and you're going to take pi. Well, pi is 3.14, but we can estimate that as 3, and r we said is 5, so r squared, 5 squared is 25. Simplifying that, the 3's cancel out, you get 100 divided by 25, which is 4. The mark scheme says that your answer can be between 3.5 and 4.5, so as long as your answer is between that and you show working out, then you should get the full marks. It says here, John uses calculator to work out the height of the cone to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? Give reasons for your answer. So John uses a calculator. Well, looking at the volume of the cone and the radius of the cone, well, we've over approximated the volume. We've said it's 100. So we could argue that our estimate is slightly higher. Again, the radius is actually 5.13, which is larger than our estimate of 5. So if you think about it, our numerator, we've estimated it to be higher, and our denominator, we've estimated it to be lower. And as a result, our estimate should be higher than the exact value of this in the calculator. And you can plug this in the calculator if you want to know the exact answer, just for your own check. But so your answer will be more, because the numerator is, so we can say that the numerator we approximated is higher than the actual value, and the denominator is also higher than the actual value. And obviously, every time, in terms of rules of fractions, if you had a fraction, every time you increase this one, the answer will increase, and every time you decrease the denominator, the answer will also increase, because the numerator is directly proportional to the answer and the denominator is inversely proportional to the answer. So as you decrease the denominator, the answer increases, and as you increase the numerator, the answer increases as well. Okay, so question 16, n is an integer greater than 1. Prove algebraically that n squared minus 2 minus n minus 2 all squared is an even number. Okay. So what we're going to do is we're going to expand the brackets. So we already have n squared. So n squared minus 2 minus, and I'm going to expand as follows. The trick here is always to bear in mind the negative sign. That's why I'm putting it in brackets, because although I'm expanding the bracket, I'm still going to keep it in some form of bracket. So n squared minus 2n minus 2n plus 4. And so I can take it out of the bracket, but I have to factor in the negative sign. So I'm going to end up with n squared minus 2 minus n squared plus, so this can simplify to minus 4n. If it's minus minus or negative negative becomes a positive, so positive 4n, negative 4. Okay, so the n squares cancel out. I have a negative 2 here and a negative 4, that becomes a negative 6. So I end up with 4n minus 6. Alright, and now they're asking me to prove algebraically that this is always an even number. Now what we need to demonstrate here is that we need to factorize out something. And considering that they want to prove that something is an even number, I'm going to factorize out a 2, and you'll see why. I end up with 2n minus 3. And we can say that any number multiplied by 2 is always even, and that's a good enough proof to say that multiplying any number by 2, because it's the 2 times table and there is no odd number in the 2 times table, so that's a sufficient enough conclusion. Okay, so question 17 states there are 9 counters in a bag. 7 of the counters are green, 2 of the counters are blue. Ria takes at, I think it should say takes out. Oh, I see. Ria takes at random 2 counters from the bag. Work out the probability that Ria takes 1 counter of each color. You must show your working. Okay, so notice here she says the question says work out the probability that Ria takes 1 counter of each color. It doesn't say that she replaces each time she takes a color, so, and that's a crucial part of your calculation. So again, you can draw a probability tree diagram, which is as follows. So let's give ourselves some more space. Perhaps let's do it here. So let's say green and blue, and then again green and blue, green and blue. Okay, so 7 of the counters are green, so it's 7 out of 9, and for this one it'll be 2 out of 9 for blue. Okay, now the next probability, so the next few branches are, here's the crucial one. So once we get to this point, she's already taken out 1 green. That means there's 1 less green, but there's also 1 less counter in the bag as well. So you would say it's 6 because it's 1 less than 7, and over 8 because it's 1 less than 9. she will have not taken out any blue counters, so you still have 2, but it will still be out of 8 because there's 1 less counter in the bag. Similarly here, she's taking out 1 blue counter, but she hasn't taken out any green yet, so it's 7 out of 8. And here she's taken, so in this branch she has taken out a blue, so it'll be 1 out of 8. And now all we have to do is, again, use our probability rules. The probability that Ria takes 1 counter of each color. So she could take a green and then a blue, or a blue and then a green. And we can write that out as blue, or let's say green, and a blue, or, so let's put that in brackets like that, or a blue and then a green. And in terms of probability, we know that an and is multiplied and an or is added. So green and then blue, that's 7 over 9 multiplied by 2 over 8. So 7 over 9 multiplied by 2 over 8. Plus, because that's what an or implies, a blue and then a green. So that's 2 over 9 multiplied by 1 over 8. And now we just literally need to simplify this. So 7 over 2 is 14, and 9 times 8 is 72, plus 2 over 72. You end up with 16 over 72. No, wait, 1 second. I've used the wrong fraction here. It's 2 over 9, and that's 7 over 8. So that is, again, 14 over 72. So that'll be 28 over 72. And that is the answer. I mean, you can simplify it. You can definitely divide both by 2. It'll be 14 over 36. You can write it as that as well. So yeah, so that'll be your answer. So we could say 14 over 36, which is also an answer. Okay, so next question. ABCD is a rhombus. The coordinates of A are 5, 11. The equation of the diagonal DB is y equals half x plus 6. Find an equation of the diagonal AC. Okay, so let's use different colors here. So they're saying that this line is y equals half x plus 6. And they are interested in an equation for this line. Excuse my wobbly handwriting. Okay, now we know that these cross at 90 degrees. Yeah, you can see it visually, but also you know that when it's just a rule for the rhombus, when you connect two diagonals, the points of intersection is perpendicular to each other. Just something that you should know. Okay, so now we need to use the rule. So considering it's perpendicular, we know that perpendicular gradients M2 are equal to -1. So the product of perpendicular gradients equal -1. Okay, so we have equation 1, which we can say is y equals half x plus 6. We'll say that the gradient here is a half. And this multiplied by something should give me -1. It's basically the negative reciprocal, so it'll be -2. And that equals -1. So the gradient of this line we know already is -2. Okay? And to generate an equation of a line, you can, if you have the gradient and a point that passes through the line, i.e. in this example A, you can use the equation of a line, which is y minus y1 equals mx minus x1. That is the equation of a line, which again you can use if you have the gradient of that line and any coordinate that passes through that line, in which case we do. So you can do y minus, in this case it's 11, equals minus 2 x minus 5. Now we just put this in the form of y equals mx plus c. So y minus 11 equals minus 2x plus 10. I'll take the 11 to the other side. I end up with y equals minus 2x plus 21. And there's your answer. Okay, next question. OABC is a parallelogram. OA is A and OC is C. Okay, X is the midpoint of line AC. So AC, that's X. OCD is a straight line, so that, okay, so OC, so there is a D here, so let's draw that. OCD is a straight line, so that OC and CD is a ratio of k to 1. Given that XD, which is from here to here, equals 3c minus a half a, find the value of k. So, well, we can draw it like this. So XD is 3c minus a half a. Find the value of k. Okay. Okay, so what we can do is we know OC. We can work out CD because we can take from C to X and then X to D. We know what C to X is and we know what X to D is. That gives us what CD is. We're going to work out what OC and so now that we have OC and CD, we can use that ratio and relate it to this ratio here, k to 1. You'll see what I'm talking about. So, right, let's do C to X. So C to X. We know that C to X is it's C or OC plus we know that C to X is basically half of AC, but we know that AC is going that way, so what we can say is it's negative of a half AC. That'll be C to X. So minus a half of minus A plus C. That'll be C to X. Okay? So if we wanted C to D, it would be going from C to X and then X to D. So we have C to X, which we said is equal to minus a half minus A plus C. And we have X to D, which is what they gave us, plus 3C minus a half A. So we expand that, we get a half A minus a half C plus 3C minus a half A. But we know the half A's are going to cancel out, and what we end up with is 2.5C. So far, we've worked out what CX is, which is half of AC, because AC is going from A to C, and we know that AC is minus A plus C. Because we're going from C to X, we're going the opposite direction, we're going halfway, so it's half of negative a half of AC. and they've given us x, xd. So we add them two together and we get CD. So we've got CD. Now we can use this ratio here. They're saying that K over K plus 1 is equal to the vector OC, because they've said here is OC over the vector CD. Well, what we're saying actually is we're saying OD, because K plus 1 is the total and OD is the total length from O to C to D. And we know that OC is C and OD is C plus D. C plus OD, which is 2.5 C. So if we simplify that, we get K equals K plus 1 equal to C over C plus 2.5 C. So the C's can cancel out, so we end up with 1 over 1 plus 2.5. Okay, so we can cross multiply. End up with K plus 2.5 K is equal to K plus 1. While the K's cancel out, you end up with 2.5 K equals 1. So K equals 1 over 2.5 or 2 over 5, whichever way you prefer to write it. So 1 over 2.5, which can be simplified to 2 over 5. And that's how you solve it. There are many ways of solving it, but this is my approach, which was, again, to work out what this length is. You know what this length is. The ratio is 1 to K. So working out the proportion of this to this in terms of vector terms and this to this in fraction terms, just converting the ratio to a fraction, you can solve it, and that's what we've done here. Okay, next question. Solve algebraically simultaneous equation. Okay, now the way I like to do this is I deal with the second equation first. I do 1 equals 3x plus 13. That gives me y on its own, and then I plug y in to x squared plus y squared equals 25. So x squared plus y squared, in this case it's 3x plus 13 equals 25. End up with x squared plus 9x squared plus 3 times 13 is 39, so 39x. But you're going to end up with 39x twice. That's if you were to just expand the brackets. Plus 13 squared is 169. This equals 25. Simplifying, you end up with 10x squared plus 78x plus, what I'm going to do is I'm going to bring the 25 to the other side. I end up with 144 equals 0, and then I just solve the quadratic. From inspection, you can use the quadratic formula, but from inspection, the way I do it is I usually say, okay, what's the way to make 10x squared? So let's say you could do 10 and 1, you could do 5x, 5x and 2x, and then how do I make 144? So there's many ways, but from inspection again, it will be plus 24 and plus 3. So I know that my x, and that is still equals 0. So either this bracket equals 0 or this bracket equals 0. When this bracket equals 0, x equals 24 minus 24 over 5. when this bracket equals 0, x equals minus 3 over 2. Oh, actually, we can simplify this further, just to make things easier. You can divide all of this by 2, you end up with 5x squared plus 39x plus half of 144, that is 72. Now, you can do it by inspection. That makes more sense. 5x plus 24, x plus 3. Again, my method of inspection is looking at how do you make this one and how do you make the x squared coefficient, and how do you make the plus c, I guess, and then seeing how those two fit to make 39x. And as follows, so x equals minus 24 over 5 and x equals minus 3. And then all you need to do is literally plug in these x values into the second equation, because it's simpler. You end up with y equals minus 7 over 5 and y equals 4. That's all you have to do, is just plug them in to this equation here. Okay. Okay, so the way you can do this is you can treat these as triangles. This is basically congruent shapes. Or let's, here are your triangles. Here's another triangle. And what you can say is as follows. Once you get the hang of these are the easiest questions to score marks in. This is a 4-marker. Okay, so you know that angle, so there's many ways of denoting it, but what you can say is angle ABC equals angle BCD. You know that, okay? BC is common for both. So you say BC equals BC, so it's a common side. Both triangles basically share this side. And again, AB equals CD. So in terms of our congruency rules, you can say that triangle ABC equals triangle BCD because side, angle, side. There's a similar angle, similar. So there's a side, same side here, and then the angle in between them is the same. Same thing with this, it's angle here, and then side on each side is the same. So because of that, you could say therefore AC equals BD, and it's as simple as that. Next question. It says here, the diagram shows a hexagon ABCDEF. ABEF and CBED are congruent parallelograms, where AB equals BC equals X. P is the point on AF, and Q is the point on CD, such that BP equals BQ equals 10 centimeters. Given that ABC equals 30 degrees, prove that cos PBQ equals 1 minus 2 minus root 3 over 200, all multiplied by x squared. This is a 5-marker. It's the last question of the paper. Okay. Let's not get intimidated by it. I'm sure it's as simple as possible. Okay, so what we're going to do is we're going to label this diagram. So they've told us that this is x and this is x. AB is x, BC is x. Point P is on AF. Point Q is on CD such that BP, so BP and BQ, these are 10. Given that angle ABC, so this angle, this larger angle, is 30 degrees. Prove that cos PBQ is equal to 1 minus, okay. Okay, cos PBQ. Okay, so it seems as though we're going to have to use the cosine rule, because you've got like cos of an angle, you've got 1 minus some squares and so on. So how's about we approach it like this? How's about this triangle that I've drawn here, let's take the cosine, let's use a cosine rule on it. So PQ all squared equals minus now they told us the length, so it's, sorry, it's not minus, it's just a squared equals b squared, which is 10, plus c squared, which is 10, minus 2 times bc, 10 times 10, cos, let's call it PBQ, okay, so it looks like, you know, we're getting closer to the answer. Okay, let's make cos PBQ the subject. So first let's simplify. Equals 10 squared plus 10 squared, that's 200 minus 200 cos PBQ. So cos PBQ is equal to cos PBQ, so if we take that to that side, so we end up with 200 minus PQ squared over 200. Okay, and then, okay, so we've got this so far. Now we need to work out what PQ squared is. Well, if you think about it, here's something which maybe a lot of students might not realize, but it's something that you pick up with practice. They said that this triangle here, with this angle, is 30 degrees. And you can argue that AC equals PQ. So technically, I can use the cosine rule on this triangle in brown as well, which is what I'm going to do now. And I can still use it using this rule, PQ equals AC. I can work out what PQ is. So 200 minus PQ squared. Okay, so PQ squared, we said, is the same as AC. So PQ squared is the same as AC squared, which here, using this triangle that we've drawn, so AC squared equals x squared plus x squared minus 2x squared, which is 2bc. I definitely recommend to memorize this formula. A squared equals b squared minus, plus c squared minus 2bc cos A. And your triangle here is A, B, C, B, C. So in this case, our A is, the lowercase a is AC, our uppercase is the angle A. Okay, so cos 30. So based on this, I can substitute this as PQ squared. So let's substitute this for PQ squared here. It's x squared was 2x squared minus 2x squared cos 30 all over 200. How are we doing? Okay. Well, let's simplify this one. 200 over, so we can simplify it as 200 over 200 minus 2x squared minus 2x squared cos 30 over 200. This simplifies to 1. Okay, we know that cos 30, if you have a triangle like this, and it's a, what type of triangle we're doing? We're doing a 2-1 triangle. So this will be 30, this will be 60, and this is root 3. So cos is adjacent over hypotenuse, so cos 30 equals 2 over, well, have I done this correctly? It is, no. Okay, seem to have forgotten. Oh, that's it. So it's root 3 here, 1 and 2, and this is your cos 30 triangle. So using SOHCAHTOA, it's a right angle triangle. Using SOHCAHTOA, it's adjacent over hypotenuse. So cos 30 is that. So we can simplify that here, and you get minus 2x squared minus 2x squared. Cos 30 is root 3 over 2. This is all over 200. And then simplifying further, 1 minus 2x squared minus, the 2's cancel out, you're left with x squared let's simplify that. X squared root 3 over 200. Okay, let's see how far we are from this. They would like 1 minus, which we've got, 2 minus root 3 over 200. Okay, we need to factorize out the x squared. 1 minus 2 minus root 3 over 200 x squared. I think that's right. Yep. So that's how it goes. So the trick here was really to appreciate that you had to use the cosine rule twice, PQ equals AC, and from that you can generate 2 cosine rules and work out to this answer. I appreciate it's a very difficult question, but it's one that if you practice enough, you'll start to think like this. You'll start to think, well, you know, PQ equals AC, and I can use these angles and so on and so forth. Maybe sketching on the diagram as well using a pencil obviously, so you don't mess up your diagram in the exam, would also help with this. But yeah, so that's the answer. That's the working out there. And that's the end of this paper. So if you found this useful, please subscribe. I'll be releasing more videos. The more feedback I get, the more sort of demand I get for these videos, the more I'll make of them, the more frequent I'll make them. If you have any questions, anything that was unclear, leave them in the comments below. Yeah, so I look forward to making the next video. See you then. Bye.